In the silent vacuum of space, a new chapter in our search for life is unfolding. For generations we've gazed at the stars, asking, are we alone? Our answer may come from the James Webb Space Telescope, a golden eye designed to capture the faintest whispers of light from the dawn of time. Webb doesn't see as we do. It sees in infrared, piercing cosmic dust to reveal hidden stars and galaxies. It can analyze the atmospheres of distant worlds, searching for the chemical fingerprints of life. More than a machine, Webb is a time traveler, looking back billions of years and peering at our closest neighbors with unprecedented precision. Its mission to find habitable worlds in the Goldilocks zone, planets not too hot, not too cold, but just right for liquid water. Webb's instruments are so sensitive they can detect the subtle dimming of a star as a planet passes in front of it. From this we can measure a world's size, mass, and even the makeup of its air. We're no longer guessing, we're collecting evidence. So we turned this incredible eye toward a small, rocky world orbiting the closest star to our sun. We hoped for clues, hints of an atmosphere, the possibility of water. Science is patient, building a picture point by point, but sometimes the universe surprises us with something so unexpected it forces us to look again. With Webb, we're not just seeing, we're understanding. And as we focus on this nearby world, we prepare for answers that could change everything. The search for life has never been closer or more real. Our closest stellar neighbor is Proxima Centauri, a dim red dwarf just over 4 light-years away. Orbiting it is Proxima b, a rocky planet discovered in 2016, slightly more massive than Earth and orbiting in the habitable zone. Its year lasts just 11 days, and because its star is so cool, this close orbit could allow liquid water to exist. But Proxima b is tidally locked, one side in perpetual day, the other in endless night. Life, if it exists, might survive in the twilight zone, a narrow band between scorching day and frozen night. Imagine a world of endless sunsets, where life could cling to the edge of possibility. Proxima b is compelling because it's both familiar and alien. So close, yet so different from Earth. For years we've debated, is it barren or a water world with a thick atmosphere? Until now we lacked the tools to know for sure. With Webb we can finally move beyond speculation. We're ready to see Proxima b as it truly is. The search for life has come to our cosmic doorstep, and what we find there could redefine our place in the universe. How do you find a city on a planet trillions of miles away? You look for its light. The James Webb Space Telescope uses a coronagraph, a sunshade, that blocks a star's glare, revealing the faint glow of orbiting planets. Once the star's light is blocked, Webb spreads the planet's light into a spectrum, revealing its chemical makeup. Scientists search for biosignatures, oxygen, methane, water vapor, and for something else, artificial light. City lights, like LEDs, have a unique spectral signature, different from natural sources. An artificial light source would stand out as a sharp, unnatural spike in the data. The process is painstaking, mapping the planet's surface, measuring light from the dayside heat from the core and reflections from the atmosphere. Scientists subtract all natural sources, searching for what remains. Any unexplained light, especially on the planet's dark side, could be a sign of something extraordinary. It's a search for an anomaly, a signal that doesn't belong. If we find it, it could be the first evidence of alien technology. The hunt is on, and every photon counts. In the darkness, even a flicker could change everything. Webb is watching, and the universe is waiting to reveal its secrets. At first, Proxima b's night side was quiet, just faint, expected heat. Then a new signal appeared, a distinct spike in the infrared, matching the signature of artificial lighting. The team checked and rechecked this signal was real. But then it intensified, growing by 270% over several months. This wasn't a subtle flicker, but a dramatic brightening on the dark side of a world 4 light-years away. The implications were staggering, a profound change, witnessed in near real time. On Earth, city lights form a tapestry visible from space, each with its own spectral fingerprint. The signal from Proxima b was hauntingly similar, a concentrated, powerful light, where there should be only darkness. What could cause such a surge? On Earth, it would be like every city suddenly tripling its brightness. It suggests massive, coordinated expansion or a sudden leap in technology. The light was concentrated near the terminator zone, where a civilization might logically build. It wasn't random, it appeared structured. It looked unmistakably like a city turning on its lights. The team was witnessing something unprecedented. Was this the first sign of alien industry, or was there another explanation? The data demanded caution, but also wonder. For the first time, we saw a world change before our eyes. The universe had sent us a signal. Now we had to decide what it meant. The most breathtaking possibility: we're seeing the lights of an alien city expanding rapidly on Proxima B's night side. This techno-signature could mean a civilization is growing or switching to new, powerful lighting, but science demands skepticism. Could it be a natural phenomenon? An intense aurora from stellar flares or a massive volcanic event? Each natural explanation struggles to match the spectral signature of artificial light. Instrumental error is also possible. Webb is complex, and the team is rigorously checking for glitches. The signal is being tested, retested, and analyzed by independent teams. Only when every other explanation is ruled out can we consider the extraordinary. Extraordinary claims require extraordinary evidence. The team isn't trying to prove the lights are alien. They're trying to prove they're not. Every alternative must be exhausted before considering the extraordinary. Verification is slow and methodical, involving peer review and independent analysis. Data from Webb is compared with other telescopes, searching for corroboration or contradiction. Persistent evolving patterns strengthen the case. Random flickers suggest natural or instrumental causes. Scientists also search for other techno-signatures: industrial pollutants, chemicals with no natural origin. This cautious approach is science's strength, ensuring discoveries are built on solid evidence. The team feels the weight of the question and knows only the truth will do. The process is as important as the discovery. The world is watching, waiting for answers, and the answer must be undeniable. Only then can we say we are not alone. Whatever the outcome, this discovery has changed the search for extraterrestrial intelligence. For decades, we listened for radio signals, a search for a greeting. Now, we actively seek techno-signatures, city lights, atmospheric pollution, the byproducts of daily life. Every civilization, no matter how advanced, must produce waste heat and light, signatures that are hard to hide. Webb and future telescopes are designed to find these signs. We're no longer waiting for a message. We're scanning for footprints in the sand. If the signal from Proxima b is artificial, it would be the greatest discovery in human history. It would reshape our science, philosophy, and sense of self. The Fermi paradox, where is everybody, might finally be answered. They're right next door. Even if the lights are natural, the discovery is profound. It would reveal new planetary processes, stranger than we imagined. Either way, we win. We learn something new about the universe. The search itself is a victory, and the journey has only just begun. The universe doesn't give up its secrets easily. Each discovery opens new questions, new mysteries. The story of Proxima b is just beginning. Webb will keep watching, turning its golden eye to other worlds. We live in a remarkable time. The first generation able to ask, "Is anybody home?" and expect an answer. This is both a privilege and a responsibility. The quest for knowledge is one of humanity's noblest pursuits. So keep looking up, celebrate the questions as much as the answers. Right now, people around the world are piecing together the story of our universe, one photon at a time. Our curiosity is boundless. It drives us to build, to search, to wonder. The story isn't over. We've just turned the first page. There is much more to come, and it's going to be wonderful.